Sounds good. Hi everybody. My name is Cody Wooden, and to fulfill the last part of my master's degree in GIST, um, my final project is looking at quantifying woody cover change in the Malpai region from 2007 to 2019 using wildfire and fine spatial resolution remotely sensed data. So here's a quick outline. I'll be going over. First, I'll introduce you to the study area and kind of put some context behind the problem and why this project is needed. Then we'll go over some objectives that I had. We'll quickly kind of run through the methodology and show you the steps and my workflows. And then we'll look at results produced from the analyses. And then kind of go over the conclusions, takeaway thoughts, and then acknowledgements and questions at the very end. So this is my study area. As you can see, it's a large chunk of land. An inset map. Down in the lower portions of Arizona, New Mexico, kind of where they all meet with Mexico. It's about 900,000 acres it's a mix of federal and privately owned land, mostly large ranches. I'd say just under half of it is probably public land, so Forest Service, BLM. It's a huge ranching culture. It's sparsely populated, large rangelands, big valleys, big mountains, and like I said, not a lot of people, and lots of cattle. And even why this even came up was Miles Trapp-Hagan through the Wildlands Network works with the Malpai Borderlands group. They're a nonprofit kind of working group, a collaboration between ranchers, local stakeholders in this area, and scientists from across the board, from federal agencies to nonprofits, trying to all work towards the same goal of sustaining like the ranching lifestyle, preventing subdivision development in this area to kind of keep it as it is, and also for just keeping healthier rangeland ecosystems, improving and sustaining range health. So what's I guess is the problem here that I'll be discussing, woody cover encroachment and the land cover change that's occurred over time. As you can see in that photo in the upper portion of the slide, you go back about turn of the century, there was just kind of sweeping grasslands, and this is from a similar southeastern Arizona ecosystem. You look at that middle image from the 50s, and it's the grassland. The grass is starting to be cacti. And then on the furthest right in the 2000s, you see increased patchiness, decreased grassland, and woody cover starts to appear, that tree. The main culprits in this area, in my study area that I'm kind of looking at, are mesquite and whitethorn acacia. That's what we're trying to detect here. Both of these things, they increase patchiness and decrease grazing potential for the cattle that are run on those lands. Just that quick map and the graph, as you can see there, it's a biotic community breakdown of the study area, and as you can see, around 75% of it is some type of grassland, and those are the grasslands are because they're arid lands. It's where there's a lot of grazing going on. They're extremely susceptible to woody cover and shrub encroachment. So my project objectives here were to classify the entire study area into 4 land cover classes using multispectral data, in this case imagery. And then the second part of it was to quantify woody cover class change. So with the one woody cover class, kind of seeing how it changed over roughly 10, 11 years across the entire study area. And then compare burned to non-burned areas and quantify the woody cover that had wood cover change that had occurred in those areas, to kind of look at how managed fire plays into this. So my data that I used for this is NAEP, National Agricultural Imagery Program, data provided by the U.S. Department of Agriculture. It's free, it's publicly available, it covers the entire country. They collect the imagery using planes about every other year, every few years, depending on the state. And because I was looking at 2 different states, unfortunately, the way it lined up, the two states were staggered in the years collected. So as you can see in the table there, For the Arizona images, past, I'd use different years. The past and present years were a little bit different than the New Mexico images, but nonetheless, they were close enough, and that was kind of what I had to work with. Luckily, most of the images were pretty fine resolution, 1 meter and 60 centimeter, which is great compared to like Landsat and things where it's 30 meter, a little bit harder to tell what's actually on the ground. So here's kind of the first step of my project, was basically to classify all 4 different nape images, so the 2 from New Mexico, 2 from Arizona, into 4 land cover classes, with woody cover obviously being the highlight. And these are generalized classes to put the focus on woody cover. There was a water shadow class. The time of day that the imagery was collected by the airplane, there were shadows cast, so that kind of had like darker pixels. I had to put those into one separate class. And then, yeah, so woody cover was that. I feel like I explained the shadow class a little bit because it seems it's an interesting land cover class. So overall, the software I used for this was ArcGIS Pro, and after training the computer, I used training the software to kind of tell the difference between land cover classes. I used it was a supervised classification, and I used the support vector machines classifier. Which is pretty powerful to assign classes based on the data that I was giving it, and on some referenced Google imagery data, as well as an NDVI index, or show surface reflections to show what is woody cover and what's not. With these, after those 4 rasters were created, I assessed the accuracy with a strategy I'll mention later, and after assessing that accuracy, that kind of provided the foundation, the 4 land cover classifications used for then take the second step, which was using those rasters to combine them. So the 2 in New Mexico I stacked on top of each other, and same with the ones in Arizona, to produce basically a giant area of different pixels that show what classes had changed over time. So from grasslands to woody cover, etc. That was kind of the main change I was looking at. With those, I was able to quantify, break down and quantify, and then convert into hectares and acres how much land had actually changed. And lastly, on top of that, I selected four areas across the study area that had experienced burns, so a wildfire or managed fire, and 2 that had not ever had been burnt before, to kind of see where the woody cover was at in those places over 10 years. So yeah, from that I was able to quantify how much change had occurred within those areas. So here are the kind of results of the combined classifications that I had to do first. As you can see here, it's 4 classes. The green there is the woody cover. It makes sense that it's kind of in the mountains. As you can see here, valleys are kind of dominated by the grasslands in yellow. The main takeaway here, though, is woody cover broken down by acres. It shows a slight increase in over time of how many acres had turned into woody cover, basically. This is my accuracy assessment. I use the equalized stratified random sampling method to kind of pick and choose and verify what the machine was producing and what I was referencing. These are a lot of numbers. The main takeaway is that my overall accuracies range from about 78 to 83%, which is kind of borderline acceptable. 80% and above is usually considered acceptable. So I was impressed and being it my first time kind of doing this, that I was able to produce such a high accuracy. But also after going through all this, it kind of was clear that the grasslands and herbaceous cover class was getting confused with the woody cover class the most. So that made it kind of difficult. And so here's just kind of like three clips of one is the classified raster in yellow, kind of showing what the pixels looked like once they were fully classified. And it's the same exact image right above it. That's a natural color image from the, again, same exact spot. And you can kind of see what colors I was using and how things were assigned. The shadow class, for example, in blue, it was kind of hard to tell what the ground was underneath it, whether it was grass or bare ground. So that's why it was put into a shadow class. And the image on the left was taken right about in the same area when I went and visited down there. And that's kind of a ground level look at what that woody encroachment, that kind of those small pixels of tan and yellow and green kind of represent. Scattered woody cover, some grasslands, and a little bit of patchiness in there. So as a result of stacking those images and kind of detecting change, this was the end result. Again, I combined them just for ease and efficiency. Looks better that way as well. Again, the takeaways from this, as you can see on the far right there, is that woody cover had increased in both areas, in both images over 10 years by around 4%. Again, with the accuracies, there is a little bit of margin of error there. Yeah. As you can see there too, I kind of circled where some of the areas were most taking place, the most changes were taking place, and that was usually in the valleys where grasslands tended to dominate previously, and then we're now being kind of encroached upon. And this is a rundown of why I chose kind of to look at wildfire as a factor in woody cover encroachment in this area. There's managed and natural caused fires that occur every year, sometimes more, sometimes multiple fires within a year. This is just two maps kind of separated, looking at all the fire boundaries from 2000 to 2019. A lot of them occur in the mountainous regions. And again, those are, naturally caused. Sometimes it's the Forest Service trying to thin out, using fire to thin out the vegetation in order to prevent more naturally caused fires. But as I mentioned earlier, a lot of ranchers use fire as well to kind of clear out the woody cover within them, and again prevent more fires from sparking up. But what effect does that have on woody cover? That's kind of what I wanted to look into. So here are the 4 study areas that I chose. They fit about the same. They have very similar characteristics. They're almost the same size. 2 of the areas that I chose were comparison areas, had never experienced a burn at all, and those were compared to the areas that had experienced a burn. One area was burned twice, 2 different wildfires about 10 years apart, and the once burned area was just burned once, obviously. They're also in similar biotic communities and similar elevation, so it gives you kind of a good level playing field here, basis for comparison. And this is kind of what I ended up finding out. This is the biggest takeaway, I guess, was that the percentage of the area of these study areas in the non-burn areas didn't change much. So the woody cover class didn't increase much, didn't decrease much, but in the areas that were burnt, woody cover was decreased somewhat significantly in the once burned area, by about 10-11% less woody cover in a once burned area, and like I said, almost 3% less woody cover in a twice burned wildfire area. They had similar rates of recovery as well to kind of establish themselves. So I find that to be pretty interesting. In conclusion, one of my first big takeaways was that this type of data, this NAEP imagery, can produce a fairly accurate assessment of the land cover. It worked pretty well for me, although it was difficult to tell the difference between a lot of the classes with the different spectral band combinations. In the end, I was able to produce a higher accuracy, for the first time around than I initially thought. Another big one here, this is kind of the goal, was to find out if woody cover is increasing, and it is slightly, mostly in the valleys and foothills across the entire region by roughly 4%. I mean, there is, again, probably like a 1 or 2% margin of error there, which is a lot of land, but given my accuracies and the imagery available, that's what this produced. And over 10 years, it seemed kind of about right from what I know of the area. And lastly, fire scarred areas contained less woody cover. I mean, that was kind of what I was hoping to find out, if it can be used as a management tool in the end. And that's what I'd like to know going forward. These are just kind of some concluding thoughts. Woody encroachment is occurring in this area. The areas, the grasslands and foothills that didn't really experience fires didn't really change, no increase, no decrease, but over 10 years, burned areas did decrease in woody cover, as I said before. So that kind of told me that woody cover, to fight woody cover encroachment, you can use fire managed, and it is sporadically used. They're also, going forward, it'd be interesting to look at the other types of effects that the ranchers and agencies use to combat woody cover, such as grubbing, which is basically just clearing out the plants, and certain chemical treatments. You could use the same data to look over time what kind of effects those other methods have. It would have been interesting to know going forward, since property lines, and I wasn't really too aware of the property lines and the strategies used by individual property owners. That data just wasn't available. So it'd be interesting going further to look more into that and see where fire is being used and how it is changing over time. And just additional data, everything going forward. If I were to do this again, I'd probably like to do more fire burned and on-burn areas and look at DEMs more, looking at elevation and slope aspect, how that affects fire and woody cover. And then additional like LiDAR data, which should hopefully be covering the US in the next few years, and just using different types of imagery. So yeah, just some quick acknowledgments. I want to thank everybody at the Arizona Remote Sensing Center, especially Dr. Wim Van Leeuwen, who helped and guided me through everything, basically. Wildlands Network and the Malpai Borderland Group. Miles Trapphagen specifically helped me get this project, and to add to the kind of I guess their whole database of knowledge that they have within the science advisory panel. So I'm glad to contribute to that. And lastly, everybody at the U of A, especially in the GIST program, I really appreciate all the support and all the awesome classes and stuff we got to take and learn kind of leading up to this. So I hope it was good enough. That's all I got. And if anybody's got questions.